In Chapter 9, Section 4, we talk about our third type of conic section, the hyperbola. So we've covered our ellipse, our parabola, and now our hyperbola. Now, I'm not going to do a neat thing where I show you how to sketch a hyperbola because it's not as much fun, I don't think, as doing the ellipse. But a hyperbola is the collection of all points in the plane, the difference instead of the sum, the difference of whose distances from two fixed points, called the foci, is a constant. So the difference of any point in the plane, so from here to here, this distance from the two foci, the difference is going to be the same. The line containing the center, the vertices, and the foci is called the transverse axis. With our ellipse, we had a major and a minor axis. With our hyperbola, all of those points are on what we call the transverse axis. The line perpendicular to that line is called the conjugate axis. Now, if our hyperbola is oriented to our xy axes, that transverse and conjugate axis are on those or parallel to those, but it does not have to be oriented in that way. We'll see that as we move through our guided notes section. So let's start though with our center at the origin and the transverse axis lying along the x-axis. The equation of our hyperbola looks similar to the equation of our ellipse, except that instead of adding, I am subtracting. So I have x squared over a squared and y squared over b squared is equal to 1, where b squared equals c squared minus a squared. The difference here is that for our hyperbola, this time c is the longest of those three values. C represents the distance from the center to the focus. A represents the distance from the center to the vertex. Notice we've got center here, so center to the vertex is A, but it's shorter than C. C is the distance from the center to the focus. The vertex this time is closer to the center than the focus is, unlike with our ellipse. The transverse axis for this equation is my x-axis, and I know that is the case because it is always the positive squared term. If you flip over, if you flip over 2 pages to page 295 in our guided notes, if you're looking at the transverse axis lying along the y-axis, our equation would be y squared over a squared, x squared over b squared, and again the transverse axis is always that positive squared term. I want you to note that for a hyperbola, the a squared is always the denominator of the positive term. So we have something over a squared minus something over b squared. No matter what the numerator is, we start with that a squared being that positive denominator. Okay, so let's go back to this first page and do example 1, where we find and graph an equation of a hyperbola. Let's answer this question first. What dictates that the transverse axis is the x-axis for this equation? It's the x-axis because that is the positive term. It's the positive term. And that transverse axis is going to contains the foci, the center, and the vertices. Okay, we're going to find and graph this hyperbola now. We're given some information about it. We're told that the center is at the origin, we have a focus at -5, 0, and we have a vertex at 2, 0. So let's go ahead and plot those points in. We have center at the origin. We have a focus at -5, 0, so that is a focus. And we have a vertex at 2, 0, so that is a vertex. If I name this as focus 1, this would be vertex 2 because it's on the other side of center. Now my vertex is closer than the focus. We knew that. Our transverse axis is going to be the x-axis because it contains the focus, the center, and the vertex. So when I start setting up my equation for my hyperbola, that x squared term is going to be first. So we have x squared minus y squared equals 1. I messed up there. X squared minus y squared equals 1. That's going to be my equation. And my a squared will go under the first term, b squared will always go under that second term. So let's see what pieces we know. Well, we know that a is the distance from the center to the vertex. So a is going to be 2, which means a squared is 4. And my other vertex is here. We know that c is the distance from the center to the focus, and that distance here is 5. That doesn't go as part of our equation. B is the other value we need for this b squared value, and b is going to be equal to the square root of, because b squared equals c squared minus a squared, the square root of 25 minus 4. So b is the square root of 21. B squared therefore would be 21, and that's my equation. So we have both vertices, we have a focus, we need to plot our other focus here, that's going to be F2 over here. Our parabola we know is going to open like this, going through the vertices, but we need a little bit more definition for how wide our parabola opens. The way we can do that is to find a point, to find a value that is above and below the focus for both of those foci. Now remember when we plotted our parabola, we called that the latus rectum, that distance from the focus up and the focus down. Well, here my focus is on the x-axis, so we have an x value to plug in. So if we want to find the points above and below the foci, we can plug in x equals plus or minus 5, because -5 is over here, positive 5 is over here. Where is that parabola going to be above and below those values? Into our equation, this looks like plus or minus 5 squared over 4 minus y squared over 21 equals 1. So I have 25/4, and then let's solve this for y squared. So I'm going to move my y squared term over to the right. I'm going to move this 1 over here. So that's going to be 25/4 minus 4/4, because minus that 1 is equal to y squared over 21, which gives me 21/4 over, okay, let me take this and I'm going to work, I'm running out of room. 21/4 is equal to y squared over 21. So when I solve for y squared, I'm going to multiply both sides of my equation by 21. So what I get then is 21 squared over 4 is equal to y squared. And when I take the square root of everything, square root of all of that, I come up, that's plus or minus the square root, I come up with y values equal to plus or minus 21 halves. So 21 halves is going to be 10.5. So from my foci, I will go up 10.5 and I will go down 10.5. So from my foci, I will go up 10.5 and I will go down 10.5 from each of my foci. So up 10.5, down 10.5. And then I connect those points to my vertex to structure my parabola. So there's the points that I found to plot. I connect them to the vertices, and I can see how wide my parabola opens. Now there's a second way, if we're not oriented on the x or y axes, we have a different way using these oblique asymptotes that shape each of the parabola parts of our hyperbola, that's going to allow us to find that shape of our parabola, or of our hyperbola. Now the top of the next page is where I fill in the details about how I did this. So let's go ahead and do that. So A represents the distance from C, the center, to the vertex, and that's 2. C represents the distance from the center to the foci, and that was 5. And then B is found using that B squared equals C squared minus A squared. And that's that B squared value down here. That gives me square root 21 for B. And we're going to use this in finding this value for B and finding our asymptote equation later on in this section. So the equation of the hyperbola we said was x squared over 4 minus y squared over 21 equals 1, and we graphed it on that last page. Okay, so I was going to pull out really quickly our notes from our ellipse section, and you're going to notice that this is consistent, right? So when we were going over our ellipses, these 3 questions, A, C, and B, look the exact same. A was the distance from center to the vertex, still is. C is the distance from center to the focus, still is. And we still find B using the same equation. Okay. Back to our notes that we're working on now. Example 2. We're going to do another equation of a hyperbola. We're going to graph. This time we are given the equation to start with. So what do we know? Well, we know because our first term is the x squared term that the x-axis is our transverse axis. So it is going to contain the foci, the vertices, as well as center. We also know that since I'm not shifted center from the origin, that my center is at the origin. So I could go ahead and I could stick that on my graph. Center is origin, and since the x-axis is the transverse axis, I know that my points are going to lie along the x-axis. So I also know A is 5, and I know B is 4, because I have A squared here and B squared there always. It's always A squared in my equation of the hyperbola. The vertices, my distance from the center to the vertex is going to be A. So the distance from center to the vertex is A. So my vertices are going to be at -5, 0 and +5, 0. So I've got a vertex here and a vertex there. Now foci. My foci have a distance, the distance to the foci, let's go ahead and change colors here. The distance to the foci from center is C. So we need to figure out what C is. C is the hypotenuse in the case of the hyperbola. So C squared equals A squared plus B squared. So C is the square root of 25 plus 16 in this case. So C is the square root of 41, which is, when I plug that into my calculator, approximately 6.4. So the location of my foci are going to be at negative square root 41, 0 and positive square root 41, 0. So I'm going to go out about 6.4, 6.5, and there is a focus, and here is another focus. So I know my parabola are going to go through the vertex and open outwards, but I don't know how far up and down I need to go. So in order to sketch the opening of my parabola, I need to calculate points above and below the foci, And the value of x at the foci is that square root 41, right? So I'm going to use x is plus or minus square root 41, and I'm going to plug that into my equation, the equation that I was given to start with. So that is going to be plus or minus square root 41 squared over 25 minus y squared over 16 is 1, and we're going to rearrange those terms again to solve for y squared. So I'm going to move my y squared minus 6 over 16 to the right, and on the left I'm going to subtract 1. So square root 41 squared just leaves me with 41, and my denominator is 25, so it's going to be 41 minus 25 over 25 when I subtract that 1, which gives me 16 over 25 equals y squared over 16, and I multiply both sides by 16. So I have 16 squared over 25 equals y squared, and when I take the square root of both sides, I have 16 plus or minus 16 fifths as my values for y. So that's how far up and down I'm going to go from the focus. So from the focus, I'm going to go 16 fifths is about just over 3, right? 3 and a fifth. So I'll go up just over 3 here and down just over 3 here. Same thing here, up to just over 3, down to just below 3. Over the focus, not the vertex. So I need to slide that on out. So those are the points that I'm going through. So from my vertex, I hit that point above the focus, that point below the focus. Same thing on this other side. From the vertex, that's the point I hit above, and that's the point I hit below the focus. Now, how did I know which axis was the transverse axis? It was the positive squared term. Okay, so let's look at the next page. We already talked about how we know when we have the transverse axis along the y-axis and what our equation looks like. A squared is still in this first denominator of the positive term. Y squared is in the numerator because that is going to be our transverse axis. Okay, we're given an equation that we want to rewrite in standard form. Remember that for all of these, standard form is set equal to 1. So we are going to divide everything by 32. If I have 2y squared minus 8x squared equals 32, to get that set equal to 1, I divide everything by 32. I can see immediately that my transverse axis is going to be the y-axis because that is my positive squared term. I know that my center is going to be at 0, 0 because I haven't done anything, I haven't added and subtracted anything within that square. So here I have y squared over 16 minus x squared over 4 equals 1, and that's the equation of my hyperbola. Given this, I know that a is 4, and I know that b is 2, and I need to find c. C is going to be the square root of the sum of those squares, a squared plus b squared, so that would be 16 plus 4. So c is the square root of 20, which is 2 square roots of 5. Okay, find the vertices. The distance from center to the vertex is a. Since my center is at 0, 0, my y-axis this time is my transverse axis. I am going up and down 4 to get to my vertices. So this is going to be vertex 1 and this is going to be vertex 2. The location of those vertices, therefore, is going to be 0, negative 4 and 0, positive 4. That's where my vertices lie. Then I'm told to find the foci. The distance to the foci is going to be c. So from center to the foci, that distance is c. My foci are further on than the vertices, so we expected that. 2 square roots of 5 is about 4.5. So I'm going to go up 4.5 to get to that focus, and down 4.5 to get to that focus. Notice that the focus is really close to the vertex this time. That means the parabola isn't going to be open quite as widely. So my locations of those foci are at 0, negative 2 square roots of 5, and at 0, positive 2 square roots of 5. All right, we can answer this question, how we determined which axis is the transverse axis. That was my positive squared term. The last thing we need to do, though, in order to go ahead and graph our parabola to know how wide our parabola is, because the only way we know how to do it right now, is to find points. Well, we need to find this time how far out we go from the focus, because we have changed our transverse axis. Now we have a y-coordinate for the focus. So we need to go to those points outside the focus, to the left and the right of the foci. And that y value for the focus is plus or minus 2 square roots 5. So that's what we're going to plug into our equation to find the x-coordinates for these points that are going to give us the width beyond the focus. So we go to our equation and we say, all right, we've got 2 square roots 5 was simplified from square root 20, right? Square root 20, we're just going to use that. So when I plug that into my y for my equation, I say plus or minus square root 20 squared over 16 is minus x squared over 4 equals 1. Well, square root 20 squared is just 20. So that's 20/16 minus 1 when I move this over. So minus 16 equals x squared over 4, which gives me 4 over 16, which is just 1/4, equals x squared over 4. I multiply both sides by 4, and I get 4 equals, 4 over 4 equals x squared, which means 1 is equal to x squared. X squared equals 1. Take the square root, and I have x equals plus or minus 1. So that's the x location where I'm at this focus. So I go 1 to the, that's right, 1 to the right, 1 to the left from the focus, 1 to the right, 1 to the left from the focus. And we see that from the vertex to that point, we have the pieces, the 2 halves of our hyperbola. And like I said, because the vertex is closer to the focus, the hyperbola does not open up as widely as the last one we looked at. Okay, let's look at this next page. Example 4, we're going to find and graph the equation of a hyperbola given some information about the hyperbola. Now this is the last one we're going to do without finding our oblique asymptotes. Okay, what do we know? Well, we know that we have a vertex at 0, 4, and we have a foci, we have 2 foci. We're given both foci. And that's all we're given. So vertex is at 0, 4. X is 0, y is 4. So that is going to go up here. And then we have foci at 0, negative 7. And 0, positive 7. So my y-axis is the transverse axis. And we know this is the case because it holds our center, focus, and vertex. Okay, so this is a vertex. This is a vertex, sorry, this is a focus. This is a focus. So if one vertex is at positive 4, the other vertex is going to be at negative 4. Okay, let's see what we've got. So our equation of our hyperbola, because the y-axis is the transverse axis, is going to be y squared over a squared minus x squared over b squared equals 1. A is that distance from the center to the vertex, and the distance from center to the vertex in this case is 4, so my a squared is 16. C represents the distance from the center to the focus, and that distance here is 7. That doesn't go into our equation. B is found using b squared equals c squared minus a squared, and that is going to be that other term in our denominator here. So b squared equals c squared minus a squared. Let's do that. We're going to do c squared is 49 minus a squared is 16 equals 33. So b is the square root of 33. B squared then is just 33. What do we need to finish sketching our hyperbola? Well, we know our center is at 0, 0. Center is at 0, 0, and we know that because it is equidistant between the foci. We were given both foci, so we're good with that. What else do we need? Well, we need to know those points above and below, out from the foci. So to get those points that go out from the foci, points beyond the foci, we know that at the foci, y is equal to plus or minus 7. So that's what we're going to use. And when we plug that into our equation, we have plus or minus 7 squared over 16 minus x squared over 33 equals 1. I rearrange my terms, and I'm going to have 49 minus 16 over 16 equals x squared over 33. That gives me 33 over 16. So when I simplify that, I get 33 over 16 equals x squared over 33. To solve that, I multiply both sides by 33. So I have 33 squared over 16 equals x squared. I take the square root of both sides, and I get values for x at plus or minus 33 fourths. Well, plus or minus 33 fourths. How many times does 4 go into 33? I'm going to grab my calculator because I don't want to miss that today. That's going to be 8 1/4. So that comes out to be 8 1/4. 8 1/4. Plus or minus 8 1/4 from, that's my x value. So I go out 8 1/4, and I'm going to be over from the focus, that 8 1/4, to the right and to the left. So from the focus, so this is going to be a little bit wider, right? So from the focus, I go out 8 1/4 to that x coordinate, 8 1/4 to that x coordinate, and then I sketch from the vertex through those points a nice wide hyperbola that opens up and down because my center, my transverse axis, is the y-axis. Okay. Finding asymptotes. Now, we are going to not work through this derivation process because it's unnecessarily confusing. What we're going to focus on is this box, okay? We're going to focus on this box. Now, instead of finding these additional points that we've been calculating, the points that would be kind of on that latus rectum out from the focus, we can instead say, you know what, our hyperbola is structured based on these oblique asymptotes. So how can I find these oblique asymptotes? If I can sketch this box and draw these lines that go through the corners, then I can use it to shape my hyperbola. Well, the size of this box, because I go out B, is going to be 2B by 2A. And we already know the values for A and B. The box goes from vertex to vertex, And then from center, it goes up B units and down B units. So that box is going to allow me to structure my oblique asymptotes that allows me to structure my hyperbola. Now we are going to be asked for the equations of the oblique asymptotes. So those equations are going to be as follows. If my x-axis is transverse, the equations are plus and minus b over a. If, however, my y-axis is transverse, my equations are plus and minus a over b. Now what I want you to notice is that the numerator is always going to be the denominator of the y squared term. So whatever is below my y squared term is what goes in the numerator of the equation of the asymptote. Now these are the equations for the oblique asymptotes where my transverse axis is not shifted away from the origin. Those equations of my oblique asymptotes get a little bit more complex when I look at shifting the center away. We're going to look at that in just a second. Let's practice right now. Alright, analyze this equation, y squared minus x squared over 16 equals 1. Okay, so I haven't messed with my x squared and y squared, so I see that my center is going to be at the origin, so I can plot the center at the origin if I want to. I know some things. I know because this would be y squared over 1, I know that a is 1, and because this is b squared, I know that b is 4, and I can find c by adding the sum of those squares and taking the square root. So that's going to be c is the square root of 17, which is about 4.1 when I go to graph using c. So I'm going to find the vertices. I also know that my transverse axis is the y-axis because y squared term is positive. So from center, I'm going to be moving up and down to get my vertices. My vertices, the distance for the vertex is a. Center to vertex is a. So my vertices are going to be at 0, -1, and 0, +1. So from center, I'm going to go up and down 1 to get to the vertices, vertex 1, vertex 2. Then I'm going to find my foci, and the distance for the foci from center to the foci is c. So my foci are going to be up and down from center, so 0, negative square root 17 and 0, positive square root 17 are the locations of those foci. And remember we said that's just a little bit past 4. So there's foci 1 and foci 2. So we know our parabola are going to be opening up and down. Now at this point we would typically find those x values associated with the y value at the foci. There's another way to do it. We can build our box and sketch our asymptotes. We're going to do this a couple of ways. First, we're going to find the equation of the asymptote. The equation of the asymptote, where our y-axis is transverse, we're going to use this value, a over b. So our asymptotes are going to be plus or minus a over b times x. So the equation for this, we have y equals 1 over 4 plus or minus 1/4 x. So our oblique asymptotes have a slope of 1/4, positive 1/4 and negative 1/4. The other way to look at this, is to say, you know what, we have moved a units up and down, so that is 2a. Now if from here I go out b, so I go b in both directions, this length of this rectangle is 2b. So I have 2a times 2b. If I sketch, let me find my straight edge, if I sketch an asymptote through the corners of that box. The slopes of these lines that I'm sketching are 1/4. Rise over 1 to 1/4. I go down 1/4, or I can go up 1/4. Those are my oblique asymptotes through the corners of that box. That box is a 2A by 2B rectangle. Now I use, from the vertex, I use this asymptote to show me that, you know what, this is going to be a really open parabola, because that box, that slope is really small, 1/4. So my parabola is going to open really, really wide. When I'm using the equations for my oblique asymptotes, I don't have to find those additional points. Alright, let's look at the note. Which axis was the transverse axis? It was my positive, y squared was my positive squared term. Sorry, I nearly forgot to answer that one. Okay, we are getting close to being done. We are not going to do the final application problem because it's just too confusing trying to set it up. I struggle with visualizing it, so I'm not going to make you guys visualize it. Okay, analyzing this equation of this hyperbola. You know what? We've got several hyperbolas left. This is already 36 minutes in. I'm going to pause this video, and I'm not going to pause it, I can't. I'm going to stop this video, and we will pick up with a second part to our 9-4 lecture.